So data in computer systems is structured numerically. So you know that ML algorithms are able to process only data if it is in the form of some numbers or it is in a numerical representation, right? So linear algebra often plays a very important role to represent the data and to analyze the data. So for that we basically use vectors and matrices, right? So we have already gone through what is a vectors are, what are matrices are, right? So vectors means it is a list of values arranged in a single column or a row, right? So this is an example for a vector. Here we have three features, that is height, weight and age. So it is represented as a vector. Within the square brackets we have represented the values of height, weight and age. So 170 corresponds to values of height, 65 corresponds to value of weight and age corresponds to value of age. 21 corresponds to value of age, right? So this is a 3 by 1 matrix, or even you can represent it as a 1 by 3 matrix also. That is also fine. That is 170, then 65, then 21. Okay, single row and three columns. That is also okay. So the corresponding vector representations are shown in this diagram, where we have one is a weight vector, one is the age vector, and one is the height vector. Now, in physics, we know that vector has a magnitude and direction, right? In mathematics, we say that vector is an ordered collection of numbers. For example, V is a vector of, it has components 3 and 4. So it represents the position or a direction in the space, and it can be plotted using a graph also. Now this is the representation of the vector in the form of a graph, where we have represented the vector 3, 4. So 3 units in the x direction, or to the right 3 units, and 4 units up in a 2D space. So this is a diagrammatic representation of the vector 3, comma 4. So in mathematics, vectors often represent some position in space. Now it has direction and magnitude also, right? Now the vector spaces can be one dimensional, or it can be two dimensional, three dimensional, or it can be n dimensional, right? If we have a single feature like temperature, then we say that suppose x is equal to 30, temperature is equal to 30 degree, means we say it is a one dimensional vector. Okay. And to example for two-dimensional vector is given here. We have two features, height and weight. So x is equal to 170, that is the height of a person, and 65 is the weight of the person. So it is an example for 2D. Okay. So this is represented here, 2D plane. We have represented the height and weight of three students. How a 3D plane means it will have three features. Example, height, weight and age. So it is a 3D vector, or it is represented in a three-dimensional space. And if you have n features, it is represented in an n-dimensional space. Okay. So the image vectors and all, they will have many dimensions, right? More dimensions than 2D or 3D, etc. Now, what do you mean by the norm of a vector or a length of a vector? So we can find the length of a vector or magnitude of a vector or norm of a vector. So we can find the norm of a vector using this formula. Suppose x is a vector and the components are 3, 4. Then what we can do, take the square of those components of vector, that is 3 square and 4 square. Perform addition on that, that is 3 square plus 4 square, and take the square root of it, that is root of 3 square plus 4 square. So we have 9 plus 16. Okay, we get 25, root of 25, which is equal to 5. Okay, so this gives the norm of a vector or the length of the vector. So this can be done as a tutorial. And now the next thing that we have to learn is how we can measure the similarity of the vectors. Okay, we can check whether the given vectors are similar or not using two techniques. One is using the dot product and one is using the Cosine similarity. Okay, so first let us see what dot product is. So it is a technique which is used to measure how similar the vectors are. Suppose you are given two vectors, you are going to check whether they are in the same direction or they are whether they are perpendicular to each other, that is whether they are orthogonal vectors, or whether they are pointing in opposite directions. Okay, if they are very much similar means they will be pointing in a similar direction. If they are not at all similar means they will be orthogonal, okay, or perpendicular, and sometimes it may be in opposite directions also. It may not be that similar. Okay, so that is actually checked using a method known as dot product. The second technique that we use is by measuring the cosine similarity. So first let us look what this dot product is. So it measures the similarity between vectors, and we have a formula to compute the dot product. A dot B is equal to sigma is equal to 1 to n ai bi. Okay, that is, it can also be, this is the algebraic representation of dot product, and it can be geometrically represented as A dot B, or the dot product of two vectors A and B is given by A dot B is equal to, this is the norm of the vector A, or the length of the vector A, length of the vector B, into cos theta. So theta means it is the angle between two vectors, and if theta is equal to 90 degree, that means that two vectors are perpendicular or they are orthogonal. Okay, so in this technique we actually consider magnitude and direction. So this direction in terms of data science, it refers to some patterns. Okay, magnitude means, we are suppose one of the vector is representing a information of how many times the user has seen a movie. Okay, so it carries some information, right? That is a magnitude here. And direction means the pattern, or how often does he visit, or what kind of movies he watch. That may be a pattern, or it can be called as a direction. Okay, so whenever this magnitude and directions are important, okay, we use dot product to measure the similarity between two vectors. Okay, so whenever only direction is important, this magnitude doesn't matter for application, then we will go for the second method, that is measuring cosine similarity, and see whether the vectors are similar. Okay, so dot product is a method used to measure the similarity between two vectors whenever this magnitude and directions are important. Whereas cosine similarity is again another method to measure similarity between vectors, where magnitude is not important but only the direction or the pattern is important. Okay, so this is a formula to compute what, the cosine similarity. So this is a formula that we are going to use to measure the cosine similarity. So A dot B is equal to sigma of I equal to 1 to n ai bi. Now, again, the example for a negative correlation can be like, when the age of the car get increases, the price that we get for the car may decrease, right? Or whenever the screen time is increased, okay, then the amount of sleep that we get decreases. So that is an example for negative correlation. So these values of what this dot product implies these things. Okay, so it helps us to measure how important two vectors are, or how much related each vectors are. Now let us look into a problem here. So here we are asked to check whether these two vectors are similar. Okay, whether they are orthogonal. Orthogonal means they are independent. So what is the condition for orthogonal? When after computing the dot product, if you get the value as 0, it indicates that it is orthogonal. So how it is, let us look into this example. So how this dot product is being calculated? First, we multiply A dot B is equal to this 0. Okay, A1 into B1, that is 0 into this 1, plus B1 into B2, that is 1 into 0. Okay, that is given here. A dot B is equal to 0 into 1 plus 1 into 0. So 0 into 1 is 0, 1 into 0 is 0, that is equal to 0. So what does this dot product indicates? If the dot product is equal to 0, it indicates the vectors are orthogonal. Okay, now The second technique is known as cosine similarity in machine learning. Cosine similarity, again, it is used to measure the similarity between two vectors, and this is used whenever the direction is important, not only when the pattern is important. The magnitude is not that important. In that case, we go for this technique. So how it can be calculated? Cos theta is equal to a dot b dot product of two vectors a dot b by unit vector or norm of a vector a and norm of the vector b. Okay, and it also ranges from 1 to -1. In dot product we doesn't have a range like thing, but if we have a positive correlation, then the value will be in the similar direction. If two vectors are, then the value will be greater than 1. Orthogonal means it is equal to 0, and less than 0 will indicate they are in opposite directions. Okay, but here in cosine similarity, if they are similar means they will obviously have a value of 1. Okay, when two vectors point in opposite direction, they will have the value -1. And if they are not similar means it will have the value 0. Okay, in case of this dot product, when we can see that when they are similar, the dot product can be 10, it can be 20, it can be 30. Okay, it can be any value greater than 0. But in cosine similarity, it is not the case. If the two vectors are similar means they will always have the value 1. Okay, that is the difference. So it ignores the magnitude and it only focuses on the direction or the pattern or the similarity. Okay, it's used when the data is high dimensional. So let us look into a numerical example. You are given two vectors A and two vectors, second vector is B. So the dot product of A dot B is equal to, we'll compute the dot product, 1 into 0, right? 1 into 0 plus 0 into 1, right? So you got a dot product of 0. Now, in order to compute the cosine similarity, we have to compute the unit vector or the length of the vector or norm of the vector A and norm of the vector B. So how you can compute the norm of the vector A? So the A vector means it is given as what, 1 0. So how the length will be calculated? Root of 1 square plus 0 square. Okay, so it is equal to 1. And how the length of b will be calculated? It will be root of 0 square plus 1 square, so it is equal to 1. So we got the dot product, we got the magnitude of a and b. Now we are going to measure the cosine similarity. Okay, cosine similarity, cos theta is equal to a dot b by unit length of a and length of b, right? So it is calculated as 0 divided by the magnitude of vector A is 1 and magnitude of vector B is again 1. So 0 divided by 1 into 1. So it is equal to 0. So what does the 0 indicate? 0 indicate that it is an orthogonal vector. Okay, since we got the cosine similarity or cos theta is equal to 0, it indicates that it is orthogonal or they have no similarity. Okay, suppose it was equal to 1 means it means that two vectors are very much similar. Okay, let's see another example. We have two vectors 3, 4 and 6, 8. Now we are going to compute the dot product of, we are going to find the cosine similarity of these vectors to check whether they are similar, they are orthogonal or they are in points in opposite direction. So a dot b is equal to, how we will compute the dot product? Dot product is equal to 3 into 6 plus 4 into 8, right? So what you get? The value is 50. Now magnitudes of vector a and vector b has to be found. So how we compute the magnitude of vector a? Root of 3 square plus 4 square. So we get the value is equal to 5, and the length of vector b can be found by root of 6 square plus 8 square, which is equal to 10. Right? Now we compute the cosine similarity. What is the formula? Cos it is equal to a dot b by length of vector a and length of vector b. So it is 50 by 5 into 10. So we'll get equal to 1. So what is the meaning of 1? 1 means a vector points in the same direction. Okay, that means your vectors are very much similar. Okay, you can see B is double of A, right? So they obviously point in the same direction. Now, this question you can do it as a homework to find the similarity of vectors. So, you're given four vectors. You have to check whether which all vectors are similar, okay, or which all vectors are dissimilar, which all vectors are orthogonal, which are pointing in opposite direction. So, what you have to do, you have to compute the similarity using dot product as well as using the cosine similarity. So how you'll check? You'll first find A dot B. You check A and B are similar. Then you check A and C are similar. Then you check A and D are similar. Then you can check whether B and C are similar. Okay, and then you can check whether B and D are similar. And after that, you can check whether C and D are similar. Okay, these many steps you have to do. That is using both what cosine similarity as well as using the dot product. You have to check it. Okay. So if U is done here, A dot B, you will find whether A dot C, you will find the dot product of A dot D, and you will have some inference also about that. Likewise, cosine similarity of A dot B, A dot C, A dot D, again B dot C, B dot D, again C dot D, all you have to find. Okay, and check whether and make a table like this and check. Give the what is your interpretation about each one when you compare two vectors. So that is left as a exercise to you.